I'm sharing the PPT with you. So today we are going to discuss about growth function, right? And screen is visible to everyone. Yes, dear students, screen is visible.
Yes, sir, visible.
Okay. So now, once again, we are going to discuss how we can execute, how we can analyze our algorithm, right? For that, we are going to discuss. So growth function is a part of this. Let's suppose this is my algorithm. Let me, right? This is my algorithm. So in this, we have few steps. A step C1, C2, C3, and so on up to C8. So in first step, what we have one for loop, which is going to execute from J to A, right? So J to A is going to execute, and each time this value is going to transfer to this key, right? So how many times this loop executes? Let's suppose if A is n times, if value of A is n, how many times this loop executing? If J starts from 1 to A, means 1 to n. Now this loop executing up to n minus 1 times. Clear? If value of A is n, J executing up to n minus 1 times. So each time we are going to transfer our value to this key, right? And here we can also write like this way. This is another logic. Second one is I equals to J minus 1. This is the condition one step more. Now again we have one more loop while I greater than 0 and A of J greater than key. What it means? Let's suppose what value we are going to pass here in this key. Let's suppose initially we have two value J equals to 2. understanding very smoothly. At any point, if not clear to you, just let me know. Then A of j means A of 2, that value is going to transfer in this variable key, right? And next, I equals j minus 1. If j is 2, what the value of I is here? J minus 1. J is 2, 2 minus 1 equals to 1, right? So value of I is 1. 2 minus 1. So this process is going to execute. Now, uh, with respect to this while loop, what we have here, right? A of I is going to transfer in this value, this. Here is minus I. I think minus is like, let me add it. Like this, right? I equals to I minus 1. We are going to decrease. And again, we are going to process this value I equals to I plus 1. Right? Here we are going to add some value here. A of I is going to pass. Means this is the process where we are going to write any algorithm. In this way, we are going to analyze. Right? This is the understanding which I am going to share you, telling you. Like in this way, we need to calculate how many times this is going to execute, how many times this going to execute, right? And so on. Like example, if we are going to execute here the same example we are going to discuss. Initially we have two values. What we are going to do here we have two values. We are comparing here values. If and j greater than key, what value we have at key is fixed, right? So that value is going to compare with A of j. Like this way. Let's suppose what we are going to do here initially we have 5 and 2, right? Which value is large, that is going to transfer in next place. We are going to swapping two values. So next slide we have here 2 5. Now 5 and 4 is going to compare. Then here we have 2 4 and 5 value. We are going to sort. We can write algorithm, we can write program as well as, right? After that 5 and 6 we are going to compare, no change. Then last we have 1 and 3, right? So this value is going to share with, again, this is the key 6, right? Now key becomes, initially we have what key 5, till now it is going to swapping. When it stops, it becomes 6. Now key becomes 6, right? Now 6 and 1 is going to compare. Again it is going to add at first place, right? So in this way, in few steps we are able to sort our algorithm. Clear? So this is the way we can read our algorithms, we can read our programs, and how many times this is going to execute. total time we are going to execute, right? We are going to calculate this total time. At first pass, it is going to take how much time? To me, at C1n, C2n1 n minus 1, C3 0 to n minus 1, because here initially we have one barrier, right? Like this, C3. Then after that, we are going to, there is no swap, right? So then again we are going to calculate. Next at C4, C4 n minus 1, total time taken by this whole equation is like Cn, C1 constant term. C1 is a constant, n plus n minus 1, n minus 1, because third time we are not sorting 5 and 6. It is not, we are not taking any time. At which place? At this place, because it is already sorted. So that's why we write here 0. That's why here the C3 is 0. C3 is, then C4 n minus 1, and C5 again we are going to start from this process. Then C6, it's depend upon the tasks, how much time it is going to sort. Clear? So in this way we are going to analyze our program. Yes, students, first tell me, anyone has any doubt? Yes, raise your hand if you have any doubt in this, because we are going to do so many examples like this, so many algorithms we are going to study. Because if starting base is not clear to you, then it may be take so much time. If any query, okay, fine. So I'm moving to the next slide. So can anyone tell me, like, what type of equation we are going to create here? It's a linear equation. So this is called a linear growth, we can say, like Cn1 minus 1 0, then so on, n minus 1 C8 again n minus 1. So it becomes a linear equation. And the worst case becomes when the growth becomes n square. Right? We are going to discuss properly all the things in further examples, right? How we are able to create. Let's suppose, so this case is clear to everyone till now, linear growth. Now worst case becomes, it occurs when array is reversely sorted. We are going to sort in a reverse order. How we can sort in a reverse order? Like increasing order or decreasing order. This is an increasing order. If we need to sort in a decreasing order, then we need to find a first element and moving to the further. First, this element we will sort, 6 element will be sort, then 5, then 4, 3, 2, 1, and so on. right? So now I am going to move to the asymptotic notations, right? We will further more examples we are going to discuss about growth rate, right? But we need to learn about these things. Let's suppose here we have this is these are the notations for asymptotic notation. The first one is big O notation. That is also called O notation, big O notations, in which we can see the graph. This is the function, this is the constant of g function, g of n, right? I'm going to explain each and everything. Just I'm going to first showing you the graphs. Let's suppose this is my example here to understanding the graph. This is my 2n square equals big of n cube, right? Equals to, this is the example, and with c equals to 1 or n not equals to n0 equals to 2. See this graph also. This is the n0, right? Here we have up to n0, n1, n2, n3. This is our function, right? And first and second thing, here we have this fn. There exists a positive constant c and n0 such that 0 less than equals to means n naught, n0 less than equals to fn or less than equals to cgn, right? This is the equation. We are going to evaluate this equation with the help of this notation big O. This is the example of upper bound. When we call upper bound, when gn function is on upper of fn, right? This g function is upper to this fn, that is called upper bound. Another one, when g function is lower than fn, that becomes lower bound, right? Now how we can evaluate this? Here we have n square, we can make like n square plus n. When c equals to this, let's suppose if we have a value of n equals to, this is the constant we need to write. After that we are able to equal to this n square plus n square plus n. Let's suppose this is n cube. If value of n is 10, it becomes 100, it becomes 1000. Just giving a general example, plus n equals to 10, right? So if I am going to write here constant, here is I am going to use 1000. because here they are going to use this value 2 and not equals to 2. Here if I have a 10 value, if I am assuming n is 10, then what thing I need to write here? I need to write 100. Then we can say this function becomes more than this fn. Only in that case we can say if the value of n is 1. Let's suppose we are going to take one value 1 plus constant becomes 1000. Here the value of n is 1. Here we can take one common from this 1000, right? If we have a 1000 of n square plus 1000 of n, then we are going to take common 1000. Then that can be divided by n by 1000. If n by 1000 means n of power of 1.999, this becomes the log. This is a little bit mathematical expression, right? So if I am going to take this example, then we can say that this gn function is going to provide a value more than this fn. This is the fn. In the same way, when we have a omega, here we can write big O. This is a big O notation. Big O. Let me write here in this PPT. Right? And here is the omega. And make sure all the students are going to join on time, otherwise I'm going to mark absent. Now in this, so now here what we have, here this is example of lower bound when fn is on higher stage and cgn is a lower. This is the example which I'm going to share you. Previous example is clear to everyone? Little bit concept is clear to everyone? Yes, students, tell me. Okay, fine. Just a minute. So now in this example, let's suppose this is root n. This is omega of log n. This is the example. This is the function we have here. Here c is 1 and n naught is this. Here is the first example we have n square. How we can calculate n square? Because here we have already mentioned this is the example of n square. This value we are going to calculate soon. N square. How we are going to receive this n square? This is a reverse example to understanding the graphs. Right? So n square we have, if we are going to use n square plus n, another one is n square minus n. We have two examples. Maybe it's a positive value more than this or less than this. Right? If we have a value, this value n square plus, if we have a value 1000 n square plus 1000 n. Let's suppose our value is becomes 1000. If our c value becomes 1000, in that case we are going to represent this value like this, constant value. If again for negative also, in same way, if we are going to calculate, let's suppose this is c n cube. Right, here we have n cube. Here we are going to calculate. How we can assume? Just right now you just have to assume here this is about lower bound. If we are going to calculate, this is the n square and root of n. Let's suppose this is my omega log n, right? And we have a property n square. Second thing, if we want, we can write like this. We need to write here log n square of this log n square, then it becomes n, right? So can we write log n square? Can you write like this way? Yes, students, tell me how we can solve this expression. Here we can write 2 log n, and we break this equation with this. Do we have any identity? It's a pure mathematics. Or second way, we can write here like this, right? If we want to break this log n square, we want to create this n square property, how we can do? We need to write here log. We're going to multiply with log. So log and log is going to log of n is the reverse part, log of this log power 2, right? So in this way we can break, so n square of log n. So in this way we are able to generate this output. I'm not going to in a mathematic, I'm just going to teach you in a approximation way of how we can solve this example in this way. Clear? Little bit understanding of this example. And another one is tide bound. Mainly the question is going to ask like about these. This is a theta notation. This is a tide bound relation. Here we have C1 of Gn, C2 of Gn. Between we have a Fn function. All right. So again, we have some logics here we need to implement. You all can. Here C greater than 0, and there is a constant n greater than 0. We have a function 0 of Fn greater than this. This is the previous condition. Now we can also implement here limit. Here we have initially we already calculate 1.99 of theta n0 and power of n2. If we are going to make by this log n, then this is the again calculation. So theta is a tide bound. This is going to give a average. In general way, if I'm going to talking about this thing, this way, like big O. Big O notation is going to give you a worst case values. The worst case, right? And omega is used for best case. How it becomes worst? Let's suppose just in a general way, we can say worst and best. this is the function fn is going to, if this is equals to this cgn, this is a case where both are going to create a same value, both are going to become a equal at certain value. That becomes the worst case fn function, or we can say fn less than equals to cgn. Here when reverse is there, here the conditions are like this. When cgn is equals to this, right, that becomes the best case. But when we have a between values, that becomes the average. That's why theta having both the values. You all can see here, this is going to give the worst case, sorry, best case value, and after that this is going to tell us the worst case between both the values we have. So in this way you all can calculate all the values. Some more in detail we are going to discuss in next lecture, right? If you have any doubt, any query, you can ask. Yes students, if any doubt, any query, we are going to discuss so many things again about this topic. After that we are going to move to the next one. Okay, I'm going to share the PPT today, right? So